June 2026. The isolated giant on the Bohai Sea, the tallest building in the entire Greater China region, is not in Shanghai. It is not in the dense financial districts of Shenzhen, Guangzhou, or Beijing. It stands a staggering 462 meters over a frozen, windswept stretch of coastline on the Gulf of Bohai, exactly 12 kilometers outside the metropolitan core of Tianjin, rising out of a reclaimed mudflat that is, for all practical purposes, the middle of absolute nowhere. This is the Bohai Phoenix Tower. It is the northernmost megatall skyscraper on Earth, towering far above the regional landscape. More than 3 times the height of any structure in its vicinity. It serves as the absolute corporate monument for one of the most powerful state-linked energy conglomerates in Asia, the domestic gas and petrochemical behemoth, Sinochem Bohai Group. Ditopkelnium. Bohai Phoenix Tower, quick stats, G. Jekyll, Datdum, Desquil. Total architectural height, 462 meters, 1,515 feet. Total usable levels, 87. Project cost, over 7 billion CO, 12 billion CNY. Unique facade attribute, 16,500 plus custom curved glass panels. Foundation achievement, 20,000 cubic meters continuous concrete pour. Gkable d'Ordranville. It holds an official global engineering record for the single largest continuous concrete pour in regional history, a foundation mass larger than what was utilized beneath the mega structures of the southern economic zones. It is wrapped in more custom-engineered, geometrically twisted curved glass than any commercial structure ever conceived. And yet, it sits entirely alone, gleaming against the gray coastal mist, surrounded by empty marshland and abandoned industrial sandplots. Miles away from the historic urban core it was originally designed to crown, why would state-backed conglomerate spend more than $1.7 billion USD building a record-breaking supertall out in an unstable coastal marsh, where virtually no foot traffic exists? The answer is not a design accident. This megatower was systematically banished there. To comprehend why this engineering anomaly exists on the freezing northern coastline, you have to dissect a brutal, decade-long bureaucratic war over the most fiercely protected historic skyline in northern China. The banishment from the historic core. This is the Bohai Phoenix Tower, anchor of the desolate Binhai North Reclamation Zone. Completed in late 2019, the structure resembles a massive glass sail punching through the coastal fog, or, more accurately, a spiraling crystal flame, a direct nod to the fossil fuel fortune that financed it. But this architectural marvel was never intended to occupy this wasteland, ruined to the economic boom of 2004. Sinochem Bohai Group, the state-controlled energy titan with direct lines to regional governance, demanded a definitive architectural statement. They wanted a headquarters that would broadcast their dominance across Asia. The corporation purchased a prime plot of high-density land in the historic colonial-era heart of Tianjin, directly along the banks of the Hai River. They announced a project that sent shockwaves through the architectural community, the Hai Spire, a prominent design consortium led by Chief Structural Architect Li Zheng, won the international design competition in 2006. The blueprint called for a piercing, 400-meter glass needle, tearing directly through the center of a low-rise, culturally preserved skyline. And that is where the project met its first catastrophic roadblock. The historic center of the city is an architectural sanctuary filled with preserved 19th-century brickwork, low-slung cultural monuments, and strict municipal view corridor laws. For generations, an unwritten structural mandate dictating local planning held that no modern commercial structure could ever rise higher than the historic drum towers and central cultural pavilions. A 400-meter glass spike was not viewed as modernization. To the local population, urban heritage experts, and academic factions, it was structural vandalism. The institutional backlash was immediate and fierce. Municipal heritage bureaus warned that the tower would permanently strip the district of its historic zoning protections. The directors of the National Cultural Architecture Council openly condemned the structural scale. The Domestic Union of Architects launched an unprecedented boycott of the design phase, refusing to participate and forcing the developer to rely entirely on isolated design offshoots. Reports emerged that nearly three-quarters of the local municipal planning panel resigned in direct protest after immense pressure to approve the zoning variances. Public resistance boiled over. Thousands of local residents, preservationists, and academic groups flooded municipal feedback forums, filing formal grievances under signs reading "Preserve the Ancestral Skyline" and "History over Petrodollars." They demanded that central architectural commissions step in to veto the corporate behemoth. When local housing and construction officials attempted to push the foundations forward anyway, public outcry reached a fever pitch, demanding immediate administrative reviews. The corporate pressure failed. In December 2010, the plan to build the megatower in the historic urban core was permanently abandoned. Sinochem Bohai Group was forbidden from planting its flag in the ancient heart of the city. Instead, the entire multi-billion-dollar project was forcibly relocated 12 kilometers out to the desolate Primorsky Bohai mudflats, a reclaimed industrial brownfield that previously served as a storage depot for commercial dredging sand. It was a site completely isolated from the city's economic pulse, deep outside the historic preservation boundary. Historic High River plot. 2004 plan, reject, public and bureaucratic backlash. Binhai mudflat site, current, 12-kilometer banishment to the horizon. That is the clinical reality behind Europe-scale height sitting in the middle of a coastal void. It was never an avant-garde master plan. It was a severe bureaucratic compromise, an administrative banishment. The municipal planning boards refused to allow a corporate ego trip to alter the city's historic identity. So, it was pushed to the absolute edge of the horizon, where it could be structurally monstrous without getting in anyone's way. If a multi-billion-dollar skyscraper getting exiled to the frozen mudflats of its own province is the kind of engineering narrative that exposes how these megastructures actually happen. Make sure to hit subscribe. This channel dissects the high-stakes structural standoffs that developers try to bury. Drop a comment below. If you lived in a historic city with a strictly protected low-rise skyline, would you have fought this corporate glass needle? Or would you have welcomed the economic density? Let's see how the community analyzes this. Now, back to the engineering. Because once Sinochem Bohai secured this barren coastal plot, their structural teams constructed something that, regardless of its isolated geography, represents an absolute triumph of extreme engineering. The nightmare of the 90-degree twist. Bohai Phoenix Tower is not a standard vertical box. The entire structural profile twists. The architectural form was inspired by the geometric layout of an ancient maritime earthen fort that once guarded the mouth of the northern river systems. To translate this into a modern supertall, the engineering team rotated the building's footprint a full 90 degrees as it ascends from the massive foundation pile up to the tip of the structural spire. Structural impact. This radical rotation means that no two floor plates within the tower are identical. Every single level is precisely offset by a fraction of a degree from the plate beneath it, transforming the structural layout into a multi-year logistical nightmare of custom geometry, variable column casting, and asymmetrical load distribution. Spire 462 ma rotated a full 90 degrees from the base. Level 17, 150, maximum structural width, bulges 2 meters past the foundation footprint. Base, original maritime fort geometry. The building actually reaches its maximum physical width roughly 1/3 of the way up the structure, around level 17, where the shifting perimeter bulges more than 2 meters outward past its own foundational footprint before tapering back inward toward the sky. But that extreme twist was not purely an aesthetic stunt. On the open, freezing coast of the Bohai Gulf, the absolute primary structural antagonist is high-velocity wind load. A standard, sharp-edged rectangular tower constructed at this height on an open coastline would act as a massive sail. Under typhoon fringe winds or freezing winter gales, it would suffer from violent vortex shedding, forces that create massive lateral sway, threatening the integrity of the internal core and inducing severe motion sickness for anyone inside. The spiraling facade completely neutralizes this. The continuous aerodynamic twist dynamically scatters oncoming wind currents, disrupting the formation of organized low-pressure vortices that attempt to force a supertall to sway. The geometric dissipation is so highly effective that the structural engineers completely eliminated the need for a massive, multi-ton tuned mass damper. The immense pendulum systems that structures like Taipei 101 depend on for survival. The aerodynamic form itself is the primary structural stabilizer. The geometry conquers the wind. But before a single pane of this twisted facade could be mounted, the engineering team had to figure out how to anchor 462 meters of concentrated steel and glass into an unstable, shifting swamp. The reclaimed mudflat Croesus. Anchoring 300,000-ton stow build a megatall structure on a stable rock shelf is one thing. To drop a 462-meter monolith weighing over 300,000 metric tons onto a waterlogged, shifting mudflat on the edge of the Bohai Gulf is a profound engineering gamble. The soil mechanics of the Binhai North Reclamation Zone were completely unsuited for heavy vertical loads. The top 30 meters of the stratigraphy consisted entirely of saturated silt, industrial sand deposits, and loose marine clay, an unstable matrix that behaves more like a liquid than a solid under high pressure. If the engineering teams got the foundation calculations wrong even by a matter of millimeters, the entire tower would suffer from differential settlement, tilting violently toward the sea and shearing its own internal structural core. The China Academy of Building Research was brought in to analyze the subgrade. The verdict was stark. The building could not rest on the ground. It had to be anchored deep into the planet. Doda Piliman, Station Stratagrup Y and Piling Matret. Dimble Delta Tinball. 0 meter 30 meters, saturated marine silt and industrial sand, 0 load-bearing capacity. 30 meters 85 meters, dense interbedded clay and consolidated sand strata. V264 high-strength friction piles driven to 85 meters depth. 85 meters plus solid bedrock layer, the ultimate load-bearing anchor. Jijapal Dal-drained warball. Engineers designed a subterranean fortress. Heavy industrial drilling rigs descended on the site to plunge 264 high-strength friction piles down to a depth of 85 meters below the surface, piercing through the treacherous mud layers until they successfully bit into the solid bedrock beneath. These piles were not simple steel posts. They were interlocking concrete columns, 2 meters in diameter, forming a dense underground forest designed to lock the building's weight directly to the crust of the earth through pure skin friction and end-bearing resistance. But these piles were just the fingers holding the ground. To bind them into a single, unified structural root, the team had to construct a monolithic foundation slab, the pile cap. That would become the stuff of regional engineering legend. Thay 49 Hor Rekor, the monolithic poured design required a solid, reinforced concrete pentagonal slab, 5.6 meters thick, to sit directly on top of the pile network. To ensure there were no structural faults, microfractures, or weak seams, this slab could not be poured in sections over several weeks. It had to be cast in one single, uninterrupted, continuous torrent of concrete. If the pouring process stopped for even a few hours, the concrete would form cold joints, seams where curing concrete meets fresh concrete. Under the immense pressure of a 462-meter tower, a cold joint is a catastrophic failure point waiting to fracture. The logistics operation was launched with the precision of a military campaign. Monitored by the Regional Municipal Construction Commission. Tidecliplamum, Logistical Timeline, the Great Pour, Dequabule, Derdwaindwalm, Hour 0, 12 fleet deployments, 400-plus heavy transit mixers activated. Hour 12, 4,800 cubic meters cast. Core temperatures monitored via internal sensors. Hour 24, 10,000 cubic meters breached. Continuous aggregate supply maintained. Hour 36, 15,000 cubic meters cooling tubes pump chilled water to prevent cracking. Hour 49 Volve, 20,000 cubic meters cast. Guinness record locked. Gemplin. For 49 consecutive hours, a non-stop convoy of over 400 heavy transit mixers choked the access roads of the Binhai district. They pulled aggregate from dozens of local batching plants, arriving at the pit rim every 45 seconds. 13 massive truck-mounted concrete pumps and specialized placing booms ringed the excavation pit, vomiting a continuous river of specialized low-heat concrete into the steel rebar matrix below. The scale was staggering. Total volume placed without stopping, 20,000 cubic meters. This shattered the previous national and regional pour records, exceeding the foundation volume laid beneath the iconic supertalls of Dubai and Shanghai. Inside the thickening mass, engineers installed a complex web of cooling pipes and digital thermal sensors, because when concrete cures in those volumes, chemical hydration generates massive internal heat. If the core temperature rises too high while the outside cools against the coastal air, the thermal gradient causes the material to tear itself apart from the inside out. For days, millions of gallons of chilled water were pumped through the internal matrix to keep the core stable, while the giant set into solid stone, the foundation held. The tower began its 462-meter ascent into the northern sky. But as the floors climbed, the structural team ran directly into a nightmare of custom manufacturing, the largest, most complex glass facade ever attempted on a high-rise. T-Facade crunch. 16,500 panas of warped glass because the Bohai Phoenix Tower twists 90 degrees as it rises. Its exterior skin cannot use standard flat rectangular window units. A flat window pane on a twisting wall creates jagged edges and air gaps to create a smooth, aerodynamic surface that would glide through the coastal winds. The facade team had to enclose the tower in an incredibly complex structural envelope. The exterior skin requires more than 16,500 individual panes of double-glazed glass. And here is the catch. Because of the continuous variable rotation and the widening bulge at level 17, almost every single one of those 16,500 cold-bent panes had to be individually manufactured with unique, custom dimensions. Standard tower. Uniform flat glass, mass-produced, low-cost, simple installation. Phoenix Tower, 16,500, curved panes, custom cold-bent, independent geometry, extreme precision. The installation was an exercise in extreme structural precision, overseen by regional fire rescue and building safety inspectors. Specialized glaze crews used GPS-guided crane attachments to lift each massive pane into place. Each unit had to be aligned down to the millimeter to ensure the structural seals were perfectly watertight against the torrential summer rainstorms and freezing winter blizzards that assault the Bohai Gulf. The result is a dazzling, seamless crystal armor, the highest volume of curved architectural glass ever deployed on a single high-rise structural frame anywhere in the region. Inside this monumental shell, the developers packed a small city. High-density corporate offices for Sinochem Bohai's thousands of administrative staff, an indoor sports complex, luxury retail pavilions, high-end dining galleries, and a massive spherical planetarium suspended within the lower atrium. But as the structure reached its terminal height, the unique geography of this northern coast introduced an environmental threat that standard skyscrapers in southern economic hubs like Shenzhen or Guangzhou never have to calculate. A silent, heavy danger born from the freezing northern winter, high-altitude structural ice accumulation, ice catching met rises at 462 meters over the open Bohai Gulf. Winter temperatures regularly plunge far below freezing, and moisture-laden sea winds wrap the top of the tower in thick, dense cloud layers. This creates the perfect breeding ground for rime ice, heavy, solid ice sheets that attach themselves to structural steel. The very top of the tower's spire is constructed as an open steel mesh. This design allows the fierce coastal gales to blow right through the peak, radically reducing the lateral wind forces acting on the building's upper frame. But that open steel lattice presented a terrifying structural hazard. If hundreds of tons of ice accumulated on that mesh during a winter storm, a sudden temperature shift could cause massive, knife-sharp ice blocks to break free and hurtle 460 meters down toward the plazas and access roads below, at terminal velocity. A falling ice block of that size would easily obliterate a vehicle or puncture right through the roof of a lower glass pavilion. To prevent a catastrophic debris event, engineers designed a proprietary high-altitude ice management system. Heavy-duty, heated structural catching frames were integrated directly into the upper spire's steel skeleton. Automated thermal sensors detect ice accumulation instantly, activating localized electrical heating elements to melt the ice before it can form dangerous monolithic sheets. In a highly sophisticated closed-loop engineering feat, the runoff water from this melting ice is captured by internal drainage channels, routed down into intermediate mechanical floors, and filtered directly into the tower's massive HVAC cooling systems, using the Arctic environment to lower the building's massive energy footprint. It is, by every conceivable metric, an absolute masterpiece of modern structural engineering. But that brilliance makes the sheer, unadulterated vanity of the tower's ultimate height all the more controversial. Because when you strip away the engineering marvels and look closely at the upper anatomy of those 462 meters, you discover that a massive portion of this $1.7 billion monument is completely hollow. The anatomy of hollow height. The vanity sphere to truly understand the structural contradictions of the Bohai Phoenix Tower, you have to look exactly where the usable office floors stop and where the sky begins. Of the tower's total 462 meters of vertical altitude, a massive portion, specifically the top 117 meters, is completely dead space. Step inside the elevator core and ride it to the absolute highest occupied floor, and you are still more than 100 meters below the tip of the structure. Beyond that point, there are no executive offices. There are no luxury observation decks. There are no mechanical rooms or high-density server banks. There is absolutely nothing but a hollow, windswept steel skeleton wrapped in decorative curved glass. In the global structural engineering community, this design phenomenon has a highly specific, clinical title: Vanity Height. Du Templeman, Bohai Phoenix Tower, in structural breakdown. Diebel Diegel Didondremble. Top of spire, 462, 117 meters. Hollow steel matrix, no usable floors. Highest occupied floor, 345. Space, 345 meters. Corporate offices and commercial atriums. Ground level. Dechelbel tomable. Dedobel tomable. Vanity height is defined as the total distance between a skyscraper's highest usable, occupied floor plate and its architectural summit. It is the structural padding added to a building's blueprint for the sole purpose of inflating its stats and winning international title races. And the Bohai Phoenix Tower carries one of the heaviest loads of non-functional vanity height anywhere on Earth. Well over 25% of this entire multi-billion-dollar structure is an elaborate architectural illusion. Sinochem Bohai Group did not pay for 462 meters of functional real estate. They paid for a massive 117-meter steel crown, so their corporate headquarters could bypass every existing supertall in the northern provinces and claim the ultimate crown. Tallest structure in the entire region. The advanced structural calculations were real. The foundation engineering was real. But a massive chunk of the physical height was never about commercial space or corporate utility. It was about raw architectural dominance. It was an expensive, engineering-intensive bragging right designed to flash a corporate signal across the maritime shipping lanes of the Bohai Sea. If you appreciate this channel pulling back the glass curtain to expose which parts of these record-breaking mega projects are legitimate engineering achievements and which parts are just multi-million-dollar structural ego trips, take a second to hit that subscribe button right now. And here is the question I want you to deliberate on in the comment section. Is massive vanity height a harmless expression of engineering ambition and corporate branding? Or is spending fortunes of state-linked capital on a hollow steel spire just to claim a record something that should be aggressively called out by municipal planning boards? Sound off below. I read through the sharpest arguments to help determine which structural failure file we crack open next. Now, let's look at the broader context, because the Bohai Phoenix Tower is not an isolated incident. It is the manifestation of a wider, systemic architectural trend that has swept across China's booming urban centers over the past 2 decades. A high-stakes race for vertical height that has left several major metropolitan regions grappling with structural vulnerabilities, unfinished monoliths, and severe economic corrections. They patent a versional ego The regional cons to see where this hyper-extended height race can lead when the market shifts. One only has to look at the historical structural parallels across China's major construction corridors. For years, municipal districts competed aggressively to plant the tallest landmark on the horizon, frequently pushing engineering boundaries to the absolute limit. Consider the structural narrative of the Golden Finance 117 Tower in Tianjin's nearby high-tech zone. Tidal Kemplums, castity comparison, high-rise and structural outcomes. Die Jepigable Adrentilmdab, Tower name Trekit Haiton, steep and structural legacy. Tantlenchen, Bohai Phoenix Tower, 462 meters completed 2019. Isolated hollow spire. Golden Finance 117, 597 meters unfinished, stalled structural obsolescence. Suzhou Zhongnan 710 meters redesigned. Scaled down height cap enforced. Jekelbel. At Ardembel. The Golden Finance 117 project was designed to soar to a staggering 597 meters, featuring an incredibly complex structural frame topped with a diamond-shaped glass atrium. Construction advanced for years, swallowing vast volumes of concrete and structural steel, eventually topping out structurally. But when the underlying financing structures fractured and the speculative demand evaporated, the project ground to an absolute halt. Today, it stands as a colossal 597-meter unfinished concrete and glass ghost tower, a stark reminder of what happens when structural ambition completely outpaces economic reality. Further south, the original blueprints for the Suzhou Zhongnan Center initially called for a mind-boggling 729-meter supertall that would have utterly dominated the Yangtze River Delta. But before the deep foundation piles could even be fully linked to the superstructure, regional regulatory bodies and structural safety commissions stepped in, realizing the extreme maintenance liabilities, vertical risk factors, and energy inefficiencies of maintaining hollow architectural height. Administrative mandates forced a massive intervention. The project was completely halted, redesigned from scratch, and aggressively scaled back to a capped height of 499 meters, stripping away hundreds of meters of speculative vertical stress. Even the iconic Shanghai Tower, while a fully completed engineering marvel at 632 meters, faced immense structural and commercial criticism during its initial operational phases. Its highly sophisticated double-skin glass facade and twisting structural form, similar to the Bohai Phoenix Tower, won architectural awards, but the structural complexity created massive internal spatial inefficiencies. For years after its structural completion, high vacancy rates plagued the tower as corporate tenants balked at the specialized floor layouts and the immense structural overhead required to keep the building climate-controlled against extreme high-altitude wind and temperature variables. This the structural landscape into which the Bohai Phoenix Tower was born. It narrowly escaped the sweeping national height restrictions enacted by central structural authorities in the early 2020s, which permanently banned the construction of any new structures exceeding 500 meters and placed severe structural restrictions on anything over 250 meters. Sinochem Bohai managed to lock in their 462-meter realm just before the regulatory iron gate slammed shut on the era of unrestricted supertall construction. But while they successfully conquered the physical marshland and slipped past the administrative height caps, they could not outrun the massive macroeconomic forces that were quietly gathering on the horizon, forces that would soon transform their gleaming corporate headquarters from a symbol of permanent economic power into a deeply isolated monument to strew cultural overreach. The human anatomy of a coastal evacuation. To truly understand what happens when a 300,000-ton twisted glass monolith is dropped into an unstable maritime mudflat, you have to look past the corporate press releases and speak directly to the engineers, the safety inspectors, and the building maintenance crews who actually work within the structure. Because by early 2024, the structural anomalies of the Bohai Phoenix Tower were no longer just theoretical calculations inside a laboratory at the China Academy of Building Research. They were active, physical disruptions manifesting through the building's internal concrete core, It was mid-January during a severe Arctic cold snap when the first major alarms were triggered. Maintenance engineer Zhang Wei, who had been part of the structural monitoring team since the building's completion in 2010, was conducting a routine inspection of the subterranean structural interface on basement level 4, the lowest structural floor plate sitting directly on top of the massive 5.6-meter-thick concrete pile cap top Trepren, Det Rebral, Vernvermel, Integral deflection log, basement level 4. Dichagelbel or Dwendable, structural anchor zone, concrete pile cap interface, 85-meter friction pile matrix. Event timestamp January 14, 342 CST. Core monitoring array, fiber optic microstrain sensors activated. Detected deflection, differential movement, exceeding normal tolerances. Auditory artifacts, high-frequency structural snapping inside core walls. Jetchical build Ardrenbel. For months, the digital laser telemetry arrays and fiber optic micro-strain sensors embedded inside the central vertical load-bearing columns had been recording microscopic anomalies. The building was settling, but it wasn't settling uniformly because the tower twists 90 degrees and bulges outward at level 17. The lateral wind forces pounding the structure from the open Gulf of Bohai create an uneven, asymmetrical torque that is transmitted straight down into the foundation pile cap. The seaward edge of the foundation matrix was bearing a vastly higher concentration of dynamic stress than the landward side. That morning, Zhang Wei didn't need digital sensors to tell him something was shifting. The subterranean air was filled with a terrifying low-frequency acoustic rumble, the sound of solid, high-density concrete compressing under immense structural stress. Suddenly, a sharp, gunshot-like report echoed through the main mechanical vault. A structural shear wall, designed to absorb lateral shifting, developed a visible diagonal fracture line that spiderwebbed across 12 meters of reinforced concrete. Within minutes, municipal construction inspectors and emergency structural engineers from the local Housing and Construction Commission were dispatched to the site. The immediate diagnosis was terrifying. The structural settlement on the northeastern quadrant of the pile cap had accelerated by several millimeters over a 72-hour period due to tidal saturation of the underlying silt layers. The decision was made instantly and immediate. Partial structural evacuation of the non-essential lower commercial zones was enacted. Over 1,200 retail employees, maintenance personnel, and corporate administrative staff on the lower 15 floors were quietly ordered to clear the building. Security guards in specialized high-visibility gear redirected traffic away from the coastal plaza. Massive flatbed trucks loaded with heavy steel structural shoring beams were rushed to the site, as crews worked around the clock under emergency floodlights to erect temporary structural braces across the basement levels. To stabilize the shifting shear zone, the millimeter war below the surface, the damage figures from that single settlement shift were staggering, while the core structural integrity of the tower remained intact, thanks to the 264 deep-driven friction piles. The differential settlement caused massive localized stress fractures throughout the lower structural joints. Repairs and structural retrofitting costs over the subsequent months surged past $45 million USD, as specialty contractors had to inject high-pressure chemical grouting compounds deep into the subgrade layers beneath the pile cap to displace the invading seawater and solidify the shifting sand matrix. But the physical damage wasn't restricted to subterranean foundations. When a 462-meter tower shifts even a fraction of a millimeter at its base, that movement is exponentially magnified as it travels up the vertical axis of the structure. At the upper corporate offices of Sinochem Bohai Group, between levels 50 and 70, the structural deflection manifested as an absolute nightmare for internal architectural finishes. Foundation shift. 2 mm baseline tilt magnified axis deviation at 300 meters, 18 mm. V. Deformation of interior door frames, shattering of internal partition glass. Corporate staff reported that heavy glass office doors suddenly jammed within their metal tracks, refusing to open or close because the structural frames had warped out of plumb. Interior drywall partitions began to rip themselves apart, creating jagged tiers along the ceiling lines. In several executive suites, massive floor-to-ceiling glass partition walls completely shattered without warning under the intense compressive forces radiating through the floor plates. Debris from internal wall collapses filled the corridors, and maintenance crews had to systematically strip away decorative wall panels to inspect the massive steel outrigger trusses that connect the concrete core to the exterior perimeter columns. The glass shower. High-altitude facade fascia while internal engineering teams fought to stabilize the shifting foundations below ground. An even more visible and dangerous structural crisis was unfolding on the exterior skin of the tower. Because the Bohai Phoenix Tower is wrapped in 16,500 individual panes of custom cold-bent, curved glass. The exterior facade depends entirely on the absolute geometric perfection of the aluminum structural glazing tracks that hold each pane in place. When the structural core suffered its uneven settlement shift, those exterior tracks were subjected to intense torsional twisting. During a severe coastal storm in October 2025, the wind load acting on the twisted facade combined with the internal structural deflection to create a catastrophic failure point. At level 42, approximately 180 meters above the ground, the structural seals on a sequence of massive, 3-meter-wide custom glass panels failed completely. The localized wind pressure tore the panels out of their aluminum retaining channels. Dup Clemens, exterior skin critical Felscher Procol. Jepkielbel Doin Dal. Failure elevation. Level 42, 180 meters intermediate commercial zone. Material displaced, 3-meter-wide custom cold-bent double-glazed units. Primary cause, torsional track deflection combined with high-velocity wind. Debris trajectory. High-velocity fall into the northeast pedestrian plaza. Die Gempel Aderdantelmai. The heavy, double-glazed units weaponized instantly as they plunged down the side of the tower. They struck lower structural ledges, detonating into thousands of razor-sharp, high-velocity glass fragments that rained down across the northeastern pedestrian plaza and the main vehicle drop-off lanes. The impact sheared through structural metal awnings and obliterated the glass roof of a ground-level security pavilion. The Regional Fire Rescue Bureau immediately declared an absolute occupancy ban on the exterior plaza zones, constructing massive, reinforced scaffolding tunnels over the building's entry points to protect personnel from potential high-altitude debris showers. The developer was forced to launch a comprehensive, building-wide inspection of all 16,500 glass panels. Specialized industrial rope access technicians, clambering across the twisted, windswept facade like spiders at dizzying heights, had to manually check the structural torque of every single mounting bracket. Rope access facade inspection matrix, Binhai zone. Rope technician at 300 meters. Curved glass retaining bracket. Torque checked manually. Curved glass, structural silicon seal reapplied. For months, the tower looked less like a gleaming corporate monument and more like a vertical repair yard. Over 300 custom curved panels were found to be under dangerous levels of structural stress and had to be completely removed, leaving gaping, black holes in the crystal facade that were temporarily boarded up with heavy, industrial-grade exterior plywood, while factories in the southern manufacturing hubs rushed to fabricate completely new custom units. The cost of replacing these specialized components, coupled with the ongoing stabilization of the foundation piles, drained millions from the project's operational budget. The dream of a flawless, maintenance-free architectural flame on the Bohai Gulf had evaporated. In its place was an ongoing, deeply complex structural battle against the laws of soil mechanics and high-altitude physics, a battle that was playing out in front of an increasingly skeptical audience of municipal regulators and structural engineers. The reclamation of reality, the spreading. Risk the structural and engineering fractures running through the foundations of the Bohai Phoenix Tower are symbolic of a much vaster, systemic reckoning occurring across the entire Binhai North Reclamation Zone. This 462-meter monolith was built to act as an unshakable anchor for a magnificent, sprawling financial center, a futuristic, high-density coastal city that would draw wealth away from traditional northern hubs. But as the tower's internal core began to shift and warp, the surrounding economic landscape shifted even faster. The master plan for this isolated coastline was hyper-ambitious. Blueprints finalized by the Regional Development Commissions featured an entire cluster of record-breaking supertalls encircling Sinochem Bohai's flame-shaped headquarters. The crown jewel of this next phase was to be Bohai Phoenix Tower 2, a gargantuan, twisting megatall designed to reach a staggering 703 meters. 2 Plinkleming, Binhai North Master Plan, Architectural Speculation, Dekebel Dibbled, Dudramble. Phase 1, Bohai Phoenix Tower 1, 462 meters completed, construct. Phase 2, Bohai Phoenix Tower 2, 703 meters spall design abandoned. Phase 3, Binhai Financial Plaza, 3-tower cluster Kenswald. Dekwagul der Paintable. Had it been constructed, it would have stood as the second tallest building on the face of the planet, boasting the highest occupied floor plate ever engineered. Behind it, a third tower was designed to complete a monolithic corporate triad, signaling to global markets that this northern mudflat was the new center of the economic universe. Then, reality arrived. The global energy market faced severe structural transformations, and a tightening domestic regulatory environment completely reshaped the landscape for massive, debt-leveraged state conglomerates. Sinochem Bohai Group, which had poured billions into reclaiming this marshland and erecting its crystal spire, suddenly watched its primary revenue streams contract under shifting export dynamics and immense infrastructure costs. By the mid-2020s, financial disclosures revealed that the energy giant was facing unprecedented balance sheet pressures. The company that had aggressively spent over $1.7 billion USD on a single vanity-padded headquarters was suddenly forced to sell off non-core real estate assets, luxury corporate hotels, and regional administrative holdings across the country just to maintain liquidity and shore up its core operational reserves. Reports circulating through municipal planning forums indicated that the conglomerate was quietly weighing dramatic restructurings, including severe cuts to its central corporate and administrative staff. The very workforce that was originally meant to fill the 87 floors of the Bohai Phoenix Tower. The monument to vanity standing alone today. The Bohai Phoenix Tower stands in an increasingly precarious position. It is the tallest building in the region, built as an absolute monument to the infinite reach and wealth of a corporation that is now too far to balance its books. The grand, high-density financial quarter that was supposed to materialize around its base remains a collection of windswept, empty lots, gravel access roads, and half-finished transit links. 2012 vision. High-density mega quarter, 2026 reality. Vacant industrial plots. V. Bohai Phoenix Tower stands alone. Those 2 even taller companion towers, the 703-meter giant and its sister structure, look increasingly like relics of a bygone era of architectural excess. They exist only as beautiful digital renderings inside design brochures, projects that the current market reality can simply no longer justify or afford. The dual nature of the Bohai Phoenix Tower is now completely exposed. It is a genuine, undeniable triumph of modern engineering, a twisting, ice-defying, record-setting supertall that successfully solved complex aerodynamic and structural problems most buildings will never have to calculate. It is a masterclass in foundation stabilization and high-altitude weather management. Raised in one of the most punishing and unstable coastal climates on the planet, but it is also, simultaneously, one of the purest monuments to unadulterated structural vanity in the history of modern construction. The final verdict on the horizon is a multi-billion-dollar megatall banished to an isolated coastal mudflat because its own municipality refused. Let corporate hubris vandalize a protected historical skyline. It is a tower topped with over 100 meters of completely empty, non-functional steel framing, whose only purpose is to win an international stats race. Built to glorify a conglomerate whose financial foundations have since shifted under the weight of changing economic tides. Telepclaiming, the Bohai Phoenix Tower legacy. Dij Gelbul, Derdwayne Ball, the historic center, fought off the corporate spike and preserved its history. The aerodynamic twist tames the coastal gales without an internal damper. The 1 in 17-meter spire carries a crown of absolute nothingness over the sea. The mudflat foundation. A Guinness record poured in 49 hours over shifting silt. Jekkolbugel Adordremble. The Bohai Phoenix Tower was designed to be seen from across the maritime Gulf, broadcasting a clear, unyielding message that this corporate power and the state backing behind it would tower over the economic landscape forever. Instead, it stands as a monument to a lesson its builders never intended to teach. It proves that you can win the engineering race to the sky, you can conquer the wind, and you can execute the largest continuous concrete pour in regional history, and still end up standing entirely alone on the edge of a frozen coast, watching the era of unrestricted architectural ego slowly recede into the fog. Somewhere right now, another corporate giant is sketching another record-breaking tower into another skyline, absolutely certain that their economic moment will endure forever. But the silent, twisted glass giant on the Bohai Gulf stands as a cold warning to them all, because it answers the one question that every vanity-driven monument eventually has to face. What good is building the tallest tower on the horizon if you have to put it where no one can stand beneath it, and the absolute power it was built to celebrate is already starting to fade?